begin the experiment, you will need copper wire, electric tape, a battery, 2 paper clips, and pliers. Using your index finger, wrap the copper wire around it 5 times to form 5 loops. Make sure that these loops are nice and tight around your finger and that the loop is nice and uniform. Take the loop off your finger and use either side of the wire to wrap it around the loop so it is nice and tight and ready for the experiment. Using a knife, shave either side of the wire so it is bare, allowing current to freely flow. Now, unfold the paper clip so it can be used to hold the loop above the battery. And repeat this for both paper clips. Now, using the electrical tape, wrap each paper clip around both positive and negative sides of the battery. Lastly, using a piece of tape, stack the magnets on the battery. With the experimental apparatus ready for use, insert the loop into the paper clips. Now the loop may oscillate back and forth and not spin, however keep on trying, it will work. Now this is how a simple motor is made.
How does this work? We know magnets exert forces on objects without touching them. That's because they have a magnetic field. In the experiment, the battery pumps electrons through the wire. When a current flows through a magnetic field, the field creates a force that acts on the wire. This can be shown with the right-hand rule. Mathematically, it's called the cross product, and it looks like this. Note that the x does not mean multiplication. Point your hand in the direction of the current, shown by the variable I, then bend your fingers in the direction of the field lines, shown by the variable B, and stick out your thumb. That's the direction of the force. With this knowledge, building an electric motor is simple. Our coil of wire is suspended by 2 current-carrying paper clips so it can spin on its axis. Electric current flows in from the left, travels counterclockwise a bunch of times, and flows out to the right. Let's look at 2 points on the loop. At the top, current flows left. Let's try the right-hand rule here. Current flows left, field points up, and our thumbs show that this part of the loop is pushed away from us. Now the bottom of the loop. Current flows right, field points up. Our thumb shows that this part of the loop is pushed towards us. So there you go. The top half of the loop is pushed in the opposite direction as the bottom half, so the loop rotates, and there's your motor. Except we forgot one detail about the direction of the current. Just like how if you flip a clock upside down, the hands move counterclockwise instead of clockwise, the current changed direction. Opposite current means opposite force, so now the loop is getting pushed back the other way. How do we fix it? We're using coated wire for our loop, so instead of shaving all around the wire where it touches the current conducting paper clips, we just shave the top half. Because current only flows during half of the loop's rotation, it only feels a force during that half, so it gets pushed the same direction each time.